Let's do another proof by induction, this time a divisibility proof. We want to prove that n square plus n will always result in a value into which 2 can divide without leaving a remainder when n is any natural number. Let's begin with the base case. When n equals 1, n square plus n is equal to 1 square plus 1, which is 2. 2 is divisible by 2, so the statement is true when n equals 1. In step 2, we assume that the statement is true when n equals k, where k can be any arbitrary natural number. By substituting k into the statement, n square plus n is now k square plus k. We are assuming that k square plus k is divisible by 2. Therefore, k square plus k has to be equal to 2 times a number, since any number that is divisible by 2 can be expressed as 2 times another number. For example, 10 is 2 times 5, 12 is 2 times 6, and so on. In this example, let's call this other number p, where p is a natural number. In step 3, the final step, we need to now show that the statement is true for the number that comes immediately after k, that's k plus 1. When n equals k plus 1, n square plus n is now k plus 1 square plus k plus 1. K plus 1 square means k plus 1 times itself. Expand the brackets, and we get k square plus 2k plus 1. Add the other k plus 1 at the end. Now remember, in every induction proof, the equation in step 2 is always substituted back into step 3. In step 2, k square plus k is equal to 2p. The expanded expression here, in step 3, also has a k square plus k in the expression if we rearrange the terms in the expression like this. And now we can replace k square plus k with 2p, since they are equal, as we can see from step 2. So now we have 2p plus 2k plus 2. Now remember, the aim is to prove it's divisible by 2, so we factor 2 from the expression, and we get 2 into p plus k plus 1. P and k are natural numbers, so if we add these two natural numbers to 1, we'll get another natural number. Let's call this number w, or any other letter of your choice. We've now rewritten k plus 1 square plus k plus 1 as 2 times another number, w. This means that k plus 1 square plus k plus 1 is divisible by 2, since any number that can be written as 2 times another value is definitely divisible by 2. Hence, the statement is true when n equals k plus 1, and is therefore true for all natural numbers. Proof by mathematical induction proves a statement true for all natural numbers by establishing a base case and then proving that if the statement is true for a given number, k, it's also true for the number that comes immediately after k, that's k plus 1. Now, since 1 is a possible value of k plus 1 can be 2, then 3, then 4, and so on. This creates a chain reaction of truth, proving the statement is true for all natural numbers. Thanks for watching. Remember to like, share, and subscribe so that you can be notified on new uploads. See you soon.